Let x be a random variable that takes on values -1, 0, 1 with equal probabilities. So that means since there are just three values and they are with equal probabilities, so each has probability 1/3, that y is equal to x squared, which of the following is true. So we're talking about covariance in all the answers, so therefore we'll need to calculate the covariance, and covariance of xy by definition is exy minus exey. Um, but in this case, we know that y is x squared, so it'll be e of x times x squared minus ex times e of x squared. Substitute y is equal to x squared. So x times x squared is x cubed. So we actually end up getting the covariance as e of x cubed minus e of x times e of x squared for this problem. And therefore, to get these expected values, we need the distributions of x, x squared, and x cubed. So x is the basic one that's given, -1, the values are -1, 0, and 1 with equal probabilities, -1, 0, 1, and equal probabilities means each of them is probability 1/3, because the probabilities have to add to 1, and they are all equal. And then we tabulate x squared and x cubed, since we'll need the expected values of those also. And x squared, you just square the x values, so 1, 0, and 1. X cubed is the same as x, because when you cube these values, the -1, 0, and 1, you get exactly the same values back. So e of x is needed as summation xpx in this case. So -1 times probability of -1 plus 0 times probability of 0 plus 1 times probability of 1. So that ends up being 0. E of x squared is the summation of x squared against px. So 1 with probability 1/3. So actually, what happened here is that this 1 came twice while you were making x squared. But there is no point in just deviating and writing it as... so actually what happened here is 1, you have a 1 here with probability 1/3, and you have a 1 here with probability 1/3. So actually for x squared, you have 1 with probability 2/3, because this, and then 0 with probability 1/3. But even if you leave it scattered like this, you'll still get the correct expected value. So I just did 1 times 1/3 plus 0 times 1/3 plus 1 times 1/3. I mean, for mathematical purists, they would like to have it as 1 with probability 2/3 plus 0 with probability 1/3, and not this term. But here we're just after the quickest way of doing things, and not always for mathematical purity. So that's 2/3. And e of x cubed has to be the same as e of x, because x cubed ends up having exactly the same values as the x. So that's also 0. And now we substitute these values into this formula. That was the formula we came up with for covariance, e of x cubed minus e of x squared. So e of x cubed is 0 minus ex times e of x squared. So 0 times 2/3 equals 0. And so there are two things that we have to answer. What's the covariance? So we found covariance is 0, so it's C or D. And now we have to determine whether x and y are dependent or independent. Now, just a word of caution. We've been saying all along that if x and y are independent, then their covariance is 0. And that's something which I mentioned in the note at the end. We know that x and y are, if x and y are independent, then covariance xy is equal to 0. Yeah, that's something we've used quite a few times already in these problems. However, the converse is not true, which means that we could even have situations where x and y are dependent and yet the covariance is 0. And that's exactly what's going to happen in this problem. So you don't rush and say, oh yeah, we found the covariance to be 0, so therefore we know that covariance and independence go together. Covariance is 0 and independence go together. No. Independence means covariance is 0, but covariance 0 doesn't necessarily mean independence. We have to find dependence or independence in some other way. And then the basic definition of independent is x and y to be independent, we must have probability x equals x, y equals y equal to probability x equals x times probability y is equal to y for all x and y. However, here we will demonstrate that that's not the case. So take the case when x is 0 and y is 0. So let's first calculate this part, the probability x equal to 0, probability y is equal to 0. So okay, there is something missing here. Okay, this is probability. One third. Okay, let me just do this part. This part is not complete yet. So let's calculate probability x equal to 0, probability x equal to 0, y is equal to 0. So that means probability x is equal to 0 and x squared is equal to 0 because y is equal to 0, y is the same as x squared. And now here, when we say x is equal to 0 and x squared is equal to 0, we're just repeating ourselves. X is equal to 0 means x squared is equal to 0, and x squared is equal to 0 means x is equal to 0. So effectively, we're just saying that probability x is equal to 0, which we are given to be 1/3. X is equal to 0 is 1/3. But now let's calculate probability x is equal to 0 times probability y is equal to 0. So that will be probability x equal to 0 is 1/3, as we established. And probability y is equal to 0 means, okay, let's first just do this step. All right, so we have this step first. Probability x equal to 0, probability y is equal to 0 is equal to probability x is equal to 0 times probability x squared is equal to 0. Yeah, because y is just x squared. And probability x is equal to 0 is 1/3. Probability x squared is equal to 0 is also 1/3, 0, 1/3. So this ends up being 1/9. And we see that that is not equal to the probability x equal to 0, probability y is equal to 0. Probability x is equal to 0, y is equal to 0. So we have found an XY pair where this condition, this one is not equal to this one. And for independence, this one should equal to this one for all possible X and Y values. So therefore, we're concluding that X and Y are dependent. Now we already saw that covariance is 0. Yeah, covariance was 0. And so we have covariance 0 and we have dependent, and that was choice C.